The process of building and constructing an outdoor swimming pool involves several important steps that ensure a sturdy, functional, and aesthetically pleasing end result. The initial step is to excavate the area where the pool will be built. This involves removing the topsoil and digging out the space to the desired depth and shape. The excavation process may require heavy machinery such as excavators and bulldozers. The excavated area must be carefully measured and leveled to ensure a stable foundation for the pool. Once the topsoil is cleared, the excavation team proceeds to dig out the space according to the desired depth and shape of the pool. The depth of the excavation is determined by factors like pool size, local building regulations, and the preferences of the pool owner. Careful attention is given to accurately measure and level the excavated area to ensure a solid and stable foundation for the pool structure. During the excavation process, it is crucial to consider the surrounding environment and any potential obstacles that may affect the construction. This includes checking for underground utilities such as electrical or plumbing lines that need to be relocated or protected. The excavated area is typically slightly larger than the actual pool dimensions to allow space for the pool walls, decking, and any necessary equipment. This extra space is important for proper installation and maintenance access. The excavation stage is a critical step in building a pool, as it lays the groundwork for the entire construction process. Proper measurement, leveling, and attention to detail during this phase ensure a stable foundation, which is essential for a durable and long-lasting pool. Concrete floor. Once the area is properly excavated, the next step is to create a solid base for the pool by pouring a concrete floor. The concrete is typically reinforced with steel bars or mesh to enhance its strength and prevent cracking. The concrete is poured and smoothed to form the base of the pool, ensuring that it is level and properly slopped to facilitate water drainage. After the concrete floor has cured and hardened, backfilling is carried out. Backfilling involves filling the space around the sides of the pool with compacted soil or gravel. This process provides support and stability to the pool structure. Care must be taken to ensure proper compaction and adequate drainage to prevent settling or water accumulation around the pool. A bonding grid is an essential safety feature in pool construction. It consists of metal rebar or copper bonding wire that is installed within the pool structure. The bonding grid connects all the metallic components of the pool, including the reinforcing steel, ladder, handrails, and underwater lighting, to ensure proper electrical grounding and prevent the risk of electrical shocks. Once the pool structure is in place, the surrounding area is graded and leveled to create a smooth surface. This involves removing any excess soil or debris, compacting the ground, and ensuring proper drainage away from the pool. NH. Finish grading helps to create a visually appealing landscape around the pool and provides a safe and functional area for poolside activities. Remove concrete forms and cut expansion joints. After the concrete has sufficiently cured, the forms used during the pouring process are removed. These forms are usually made of wood or metal and provide the shape and structure during the initial concrete placement. Additionally, expansion joints are cut into the concrete. Expansion joints are essential to allow for movement and prevent cracking caused by temperature fluctuations and soil settlement. These joints are usually filled with a flexible sealant to maintain a watertight seal. Build pump and filter system. The next step involves the installation of the pool's pump and filter system. This includes connecting the necessary plumbing, such as pipes and valves, to ensure proper water circulation. The pump, filter, and other equipment, such as heaters or sanitization systems, are installed according to the pool's design and specifications. The plumbing system must be carefully planned and installed to ensure efficient water flow and proper functioning of the pool equipment. Clean up and install liner. Once the major construction is completed, the construction site is thoroughly cleaned up. Debris, excess soil, and any construction materials are removed from the pool area. Afterward, a pool liner is installed to create the waterproof surface of the pool. Pool liners are available in various materials, such as vinyl or fiberglass. The liner is carefully positioned and secured, conforming to the shape and size of the pool structure. Fill up the pool. With the pool structure and liner in place, the pool is ready to be filled with water. This can be done by connecting the pool to a water source or by having a water truck deliver the water. Care is taken to ensure that the pool is filled evenly and slowly to avoid damaging the liner or structure. Building a year-round, energy-efficient house that is also cost-effective is a dream for many homeowners. The good news is that it is now possible to achieve this goal through the ready-made house portfolio Max of the PSB Corporation. The Max 3 house is one such example that provides an excellent foundation for energy efficiency, comfort, and sustainability. The Max 3 house is a part of the Max portfolio of houses produced by the Fabrika Dom W. Spamen in Bielsko-Biała. These houses are designed and built to meet the needs of modern living, while also being energy efficient, eco-friendly, and affordable. The Max portfolio has gained popularity in recent years due to its unique features and the record-breaking time in which they are built. The Max 3 house has a unique design that allows it to be energy efficient all year round. The house is built using high-quality materials and modern construction techniques that minimize energy loss and maximize energy efficiency. The walls, roof, and foundation of the house are well insulated to prevent heat loss during the winter and to keep the house cool during the summer. The windows and doors are also designed to be energy efficient and are made of materials that prevent heat loss and reduce noise pollution. One of the key features of the Max 3 house is its ventilation system. The house is equipped with a mechanical ventilation system that provides fresh air to all rooms while also recovering heat from the exhaust air. This ensures that the indoor air quality is always high and the house is always comfortable to live in. The ventilation system also helps to reduce heating costs by recirculating the heated air back into the house. The Max 3 house is also equipped with a modern heating system that uses renewable energy sources to provide warmth in the winter. The house is equipped with a ground source heat pump that uses the Earth's natural warmth to heat the house. The heat pump is energy efficient and can provide warmth, even in sub-zero temperatures. The house is also equipped with solar panels that provide electricity for the house. This ensures that the house is not only energy efficient, but also sustainable and eco-friendly. The Max 3 house is designed to be flexible and adaptable to the needs of modern living. The house has a spacious living area that is perfect for family living. The kitchen is equipped with modern appliances and is designed to be functional and efficient. The bedrooms are spacious and comfortable, and the house is designed to provide privacy and comfort for all family members. The house also has a large garage that can be used for parking cars or as additional storage space. The Max 3 house is built using modern construction techniques that allow it to be built in record time. The house is built using prefabricated elements that are manufactured off-site and then assembled on-site. This allows the house to be built in just 6 days, which is a record time for a house of this size and complexity. The prefabricated elements are made using high-quality materials and are designed to be energy efficient and eco-friendly. The Max 3 house is an excellent example of a year-round energy-efficient house that is also cost-effective and sustainable. The house is designed to provide comfort, flexibility, and functionality while also being eco-friendly and energy-efficient. The house is built Kumoha Kimungu Shrine in Yaba-Kei-cho, Nakatsu City, Oita Prefecture, was home to a majestic 1,000-year-old cedar tree that was revered as a sacred symbol of strength and resilience. However, in 2004, a powerful typhoon broke the tree, leaving it damaged but still standing. Despite the damage, the tree continued to inspire and impress people with its sheer determination and perseverance. For 6 long years, the tree managed to survive, but its pain eventually became unbearable, and it had to be cut down on September 15, 2010. This was a tragic moment for the locals who had grown to love and cherish the sacred tree. Nevertheless, its memory lives on in the hearts of those who saw it in its prime. The Kumoha Kimungo Shrine was a popular destination for visitors who wanted to witness the majestic presence of the cedar tree. The tree was a source of inspiration, hope, and courage for many people who visited the shrine. It had witnessed numerous historical events and had been an integral part of the local culture for over a millennium. The locals hoped that as many people as possible could see the tree's last majestic figure before it was cut down. They wanted the world to know about the remarkable history of the 1,000-year-old cedar and its significance in the lives of the people of Yabake-cho. The farewell day of the sacred tree was a poignant moment for everyone who had known it, and it marked the end of an era. The Kumoha Kimingo Shrine's sacred tree was a remarkable symbol of strength and resilience. Despite its tragic end, its memory continues to inspire and give courage to people who visit the shrine. Its legacy will live on for many years to come, and it will forever be remembered as a vital part of the cultural heritage of Yabake-cho and Nakatsu City. Felling a large tree can be a dangerous and challenging task, especially for those who do not have experience or knowledge in forestry. The process involves a series of steps that require careful planning, preparation, and execution. The first step in felling a tree is to evaluate the tree and the site. The tree must be assessed for its size, lean, height, and condition. This will help determine the appropriate tools and techniques needed to fell the tree safely. The site must also be evaluated for any obstacles that may interfere with the felling process, such as buildings, power lines, or other trees. Before felling the tree, it is essential to clear the area of any debris or obstacles that could cause accidents or damage. This includes removing any branches or brush around the tree's base, and ensuring there is a clear path for the tree to fall. The next step is to plan the felling direction. The tree must be felled in a direction that ensures safety and minimizes damage. This involves identifying the tree's lean and choosing a felling direction that allows the tree to fall safely. The felling direction should also be away from any structures or other trees. Once the felling direction has been established, the felling cut can be made. The felling cut is made on the side of the tree facing the felling direction. It should be a horizontal cut that is no more than 1/3 of the tree's diameter, and should be made at a height that allows the operator to comfortably work. After the felling cut is made, the back cut can be made. The back cut is made on the opposite side of the tree, slightly above the felling cut. The back cut should be slightly higher than the felling cut to create a hinge that controls the tree's fall. The hinge should be at least 10% of the tree's diameter, and should be thick enough to support the tree's weight. Once the back cut has been made, the tree will start to fall. The operator should quickly move away from the tree to a safe location, and allow the tree to fall. It is important to remain alert and aware of the tree's movement, and ensure that it falls in the desired direction. After the tree has fallen, the limbs must be removed. This process is known as limbing, and involves removing the branches from the tree's trunk. Limbing is essential for safety reasons, and allows the operator to safely approach the tree. Once the tree has been limbed, it can be bucked into manageable pieces. Bucking involves cutting the tree into sections of a size that can be safely handled and transported. The final step is to clean up the area. This involves removing any remaining debris, such as branches or stumps, and ensuring that the site is left clean and safe.